Hello, this is the extension video where we're going to be looking at solving a linear and quadratic simultaneous equation, but instead we want to rearrange the quadratic expression. So this was one we have done previously. The first example of a linear and quadratic simultaneous. And instead of rearranging equation 1, let's rearrange equation 2 instead. So now the ideal thing is to say, right, replace y with x squared plus 3. That's another way of doing it. Just replacing it the other way. Though, let's try something else. Let's try replace x instead and see what happens. Just in case that you were wondering what's going to happen. So for equation 2, we'll note that x squared is equal to y minus 3. So note that x is plus or minus square root of y minus 3. So now we're going to substitute this into equation number 1. The only issue is that we now have two cases to consider. Let's look at case 1. Case 1 is the fact that x is going to be positive. So at this point we're having 3 times the square root of y minus 3 minus y plus 7 is equal to 0. So what we get is 3 square roots of y minus 3 is equal to y minus 7. And then to get the square root, we're going to square both sides. So we get 3 squared, which is 9, times the square root undone, because these two are going to knock each other out, to leave us with y minus 3, is equal to this thing squared, which is y squared, take away 14y plus 49. So all we have to do is just rearrange a couple of things. So we get 9y minus 27 is equal to y squared minus 14y plus 49. So y squared minus 23y plus, what's that going to give us? So 27 plus 49, that gives us plus 76 is equal to 0. So now we have to just solve this quadratic. So let's consider it. First thing I'll work out is the discriminant, which we can easily do. If you haven't met this guy yet, you can free look in the quadratic section when I post it. It just saves me time. So 23 plus root 225 over 2. So one of the answers I get is y is equal to 19. Second answer is y is equal to 4. Now, if I scroll all the way back to where this original question was, we did end up getting y is equal to 19 and y is equal to 4. It's actually handy because in this case we considered, well, the case where, well, at least the x coordinate is positive, which means that the corresponding y coordinates are also going to be positive, and that just happened to be true. However, do note when we're subbing back in, this is where it gets a little bit challenging. So let's recall that x is plus or minus square root of y minus 3. Now, we're not really sure too much about the signage because the signage can actually vary. So we're going to have to check. So for y is equal to 19, we could get an x value of plus or minus root 19 minus 3, which is to say x is either plus or minus 4, which we'll have to check individually. Though in this case, we've assumed that x is greater than 0 anyway, so we can land on x is equal to 4, but it's not fully conclusive. And then in the case of this, we have plus or minus square root of 4 minus 3, which is to say x is plus or minus 1. Though in this case, this lands on the other sense where x is negative 1. if we match our logic with the answers to the question previously. So that's why we don't generally rearrange the quadratic. It just happened to be fairly okay in this case, though generally that's not always what happens. Sometimes you can get lost in a lot of square roots for a while, and well, we haven't really formally met them. If you're following along the videos just in their usual order, though quadratic should be in your toolkit by this point. So that's just a quick demonstration on why not to really rearrange the quadratic.